Let's consider the following diagram. We have an angle whose vertex is at 2, 1. It has a measure of theta radians. We don't know that value, but we know the terminal point of this angle along this circle. And if we look at this circle, notice that the center has an x-coordinate of 2, and then the right side of that circle has an x-coordinate of 3.5, and therefore the radius of that circle should be 1.5 units. So let's suppose we want to know the value of theta. We want to know how many radians this angle is swept out. We have a few different ways to do this, but let's use the inverse cosine function. So if we're thinking about the inverse cosine function, we should also be thinking about the cosine function and what that function relates. And the cosine function relates a angle measure swept out from the 3 o'clock position and a horizontal distance measured in radius lengths. So we need to be thinking about horizontal distance in radius lengths. So the terminal point's distance to the right of the center of the circle and radius lengths. So if we looked at that horizontal distance right there, based on what we know, the x-coordinate of the terminal point is 2.544, and the x-coordinate of this center point is 2. And therefore, if we call that maybe delta x, then that's going to be the final x value, 2.544, minus that initial x value, which is the x value of the center, which is 2. And therefore, the terminal point is 2.544 minus 2 units to the right of the center of the circle. However, cosine gives us that horizontal distance, but measured in radius lengths. And so if we wanted to say something about cosine of theta, then it's actually that horizontal distance, which is 2.544 minus 2, but measured in the radius of the circle, which is 1.5 units long. Therefore, cosine of theta would give us 2.544 minus 2, which is distance to the right in normal units, but divided by 1.5 because we're measuring that distance in radius lengths. So this statement is true, and from this statement, we can think about the inverse cosine function to determine the actual value of theta. So if we're thinking about the inverse cosine function, so we're thinking about cosine inverse, recall that inverse functions, they represent like the same relationship as the original one, but they swap the input and output because they reverse a process, which essentially means that the input of cosine inverse should be the output of cosine, and the output of cosine inverse should be the input to cosine. So if we swap those around, then theta will actually be equal to cosine inverse of that 2.544 minus 2 all divided by 1.5. And therefore, this is a way for us to determine the value of theta given the location of the terminal point and the center of that circle.